Hey everyone, we're gonna kind of finish up what we did the other day with 1b. Last time we talked about how we could take a expression that has a rational exponent and rewrite it as a radical. Today we're going to do the opposite. So your goal for today, your learning objective is I can rewrite radicals as expressions with rational exponents. So just as a quick review, if we have a exponential form here, which let me go ahead and write out, this is an exponential. Oops. We wanted to write it as a radical. So what we did was we drew a radical. We identified the base, which here is x, the power, which is 1, and then the root, which is the 2. So base, power, root. We put it in that form. So our goal here is we want to go backwards now. So what happens if I'm starting with a radical and then I want to write it in an exponential form? Well, it is the exact same thing, just in reverse. There's not a whole lot of extra thought that needs to happen to it. So let's start by identifying the base here. Remember, the base may be in parentheses, and you'll see a lot of examples like this. So the base here is in parentheses, so I'm going to continue to use parentheses, right? I'm not just going to get rid of them for no reason. And then we're going to raise it to a power, a rational power, which means it's a fraction. So we need to figure out what number goes on top. Is it going to be the 3 or is it going to be the 5? Well, remember the power is the numerator of the fraction, and it is the exponent underneath the radical, so it'll be a 5. And then the root is this little number here that's kind of in this wedge of the radical. It's sometimes called the index. And that is exactly how we do it. You can kind of just match these up in the future and observe, like, okay, so where did this piece go? This piece went here. Where did this piece go? Okay, it went here. So let's look at a different example. Here we have something outside of the radical. So that is not our base. That is just going to stay outside of the radical. So I'm not going to really do anything with this 2. There should be no exponent here. The base, however, is this x. And I will raise that to the 5th power. And I will divide that by the root, which is 3. So you could see both these two problems, the answers look very, very similar, the difference being the parentheses. And this actually changes the problem a whole lot. These are very different problems because of the parentheses. You can see in them in radical form, they look very, very different there too. So let's look at another example where, again, the problems look somewhat similar. They both use 4mn, and then they have a 7 power and a 10 as a root. So again, I see parentheses, so I'm going to keep those parentheses for the base here. So 4mn, and then I will raise it to the 7th power and divide that 7 by the index or the root, which is 10. Now this is going to look slightly different when we have the 4m on the outside, right? So we got 4m on the outside. That's not the base. The base here is just this n, which I'm then going to raise to the 7 over 10 power. You could see in this example here, the third example that I did, the 7 over 10 as an exponent is affecting the 4, the m, and the n. Whereas the 7 over 10 here is just affecting the n, right? That's kind of what the parentheses do. That's something we did in 1a. And I just want to point out to you guys that the parentheses include everything as the base. Whereas here, if there's no parentheses, the base is just n. So just a key difference to keep in mind when you're going through these problems.